All right, so today we're going to start our study of trigonometry, and this is going to be a big focus for us for a good chunk of the year. Today's going to be sort of possibly a review for you, as well as just getting some of the vocabulary down. There may be things in here that are new, but we'll talk about those as they come up. So to begin, let's go ahead and just kind of go over what our goals for the day are going to be. So we want to be able to learn trigonometry vocabulary. We want to use degree measures to describe angles in their quadrants in standard location or standard position. We're going to use radian measures to describe angles and quadrants in their standard position. Finding coterminal angles and go back and forth between radians and degrees. So to begin with, we need a little bit of vocabulary defined. So if you need to pause the video here to fill in the definitions, I'll kind of talk about them here as you're writing them. So trigonometry is simply put the study of angles. That's all it is, just the study of angles. Coterminal angles are two or more angles that have the same terminal side, and we're going to talk a little bit about that later, what that means. A degree, one single degree, is 1/360th of a circle. And a radian, if you've never seen that before, which I believe you talk about it in geometry, even if it's briefly, is an angle that's formed by wrapping a radius around the outside of a circle. And again, we'll look at that more closely here in just a moment. So let's begin by talking about what it means for an angle to be in standard position. So there's three things that need to happen. First of all, the vertex must be at the origin of the coordinate plane. Okay, so if we look at our picture here, our vertex is at the origin of the coordinate plane. The initial side is the positive x-axis. So whenever we start with an angle, when we have it in standard position, the positive x-axis is going to be our initial side. That's going to be the start of our rotation. And then the terminal side opens counterclockwise. So we have this counterclockwise movement until we have the angle formed that we want, and that's called our terminal side. So the initial side and the terminal side have a vertex at 0, 0, and that's what your angle is going to be. Now, this angle can be represented with either degrees or radians, and we'll talk about that in just a minute. So we're going to draw a couple of different angles here. On the first graph, we're going to draw an angle that has a positive degree measure, okay? On the second picture, we're going to draw a negative degree measure. And on the third picture, we're going to label all four quadrants. Okay, so we're going to start with the positive degree measure. So to draw an angle, we have to first draw the initial side. And the initial side is always going to be along the positive x-axis. So I know my vertex of my angle will be at 0, 0. I will have my initial side here on the positive x-axis. Now, a positive degree measure just means it's going to open up counterclockwise. So we're going to open up in any direction that, or as far as we want here, not in any direction, as far as we want. So let's say that's our rotation. Then what we do is we draw the terminal side of our angle. So this represents the terminal side of our angle. Now that angle has a measure that's more than 180 degrees, because a rotation to right here would be 180 degrees, but less than 270 degrees, because that would be what our rotation would be if we went all the way to that negative y-axis. So it's somewhere between 180 and 270 degrees. So maybe we call it 240 degrees. Okay, doesn't matter. You pick a number there. Now we could have drawn that angle and had the terminal side really be anywhere. So that terminal side could have been in quadrant 2. It could have been in quadrant 4. All right, next up, let's go ahead and draw a negative degree measure. So negative means, again, we have to start in the same place with our vertex at 0, 0 and the positive x-axis being our initial side. The difference between a positive angle of rotation and a negative angle of rotation is just the direction in which you rotate. This gives me positive. We want to go backwards, so we rotate backwards. And again, you can rotate as much as you'd like. I'm going to do a shorter, smaller rotation here. Just going to rotate backwards like that. And then I'm going to draw in my terminal side. So that is my terminal side. Now, I have rotated less than 90 degrees. Okay, if I rotated all the way to here, that would be a negative 90 degree angle of rotation. I'm less than that, so we can call that, I don't know, maybe negative 40 degrees. All right. And then last but not least, label the 4 quadrants on the third graph. So you might never have understood, and it might have always confused you, why these quadrants are labeled in the order that they are. And here's why. When you draw an angle in standard position, we always start here at the initial side. If I'm creating a positive angle, then I rotate through the quadrants in this order. I rotate through 1, then 2, then 3, then 4. And that's how you know the order in which you're going to label your quadrants. Okay, let's move on. So the next thing we're going to talk about here is coterminal angles. Now, we defined what coterminal angles were a moment ago. And the key to finding coterminal angles is to either add a rotation or subtract a rotation from any given angle. So that is our key to finding coterminal angles in degrees. So I'm going to either add or subtract one rotation, which in degrees is 360 degrees. All right, so let's try a couple of these. So the first thing we're going to do is draw the angles in standard position. So I'm going to start by drawing the angle in standard position. Then I'm going to state the quadrant in which the angle lies, and then I'm going to find a positive and a negative coterminal angle for each of the angles. Okay, so let's start with drawing the angle in standard position. Now here's the thing, guys. You're going to be estimating this, all right? We're not going to be perfect, and that's okay. Okay, so let's start with 160 degrees. Now I need to draw the angle. So I start by putting the vertex at the origin and the initial side on the positive x-axis. All right, so that is my initial side. Now, my angle of rotation is 160 degrees. So let's talk for a second here. If we're going to rotate, and we rotate to this positive y-axis, we know that that's a 90-degree rotation. If we rotate from here all the way to the negative x-axis, well, now we've rotated 180 degrees. If we rotate from here all the way to the negative y-axis, well, now we've rotated 270 degrees. And then finally, if we rotate from here all the way back to the positive x-axis, that's going to be a total rotation of 360 degrees. So when I talk about 160-degree rotation, I have to consider where it's going to lie on the coordinate plane. It's going to be bigger than 90, but less than 180, and definitely closer to 180 than it is to 90. So I'm going to draw an angle that looks maybe like it stops right about here. Okay, so I draw in my terminal side. All right, so I have this angle of rotation that looks like it's about 160 degrees. Awesome. Now, part 2 of this process is to state the quadrant that that angle lies in. So our angle, 160 degrees, so this is a quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Our angle lies in quadrant 2. All right, next up, we need to find what we're going to call a positive coterminal angle. So what I want to do is I want to actually, from here, add on another rotation, one complete rotation. So here's what that's going to look like, guys. If you follow my green rotation. So I'm going to start here. I'm going to rotate to here, okay? But I'm going to keep on going all the way around one more time. So what I've done is a complete rotation, one total rotation, which is 360 degrees. And then I added on the 160-degree angle that I stopped at initially. So what I have is a total rotation of 520 degrees. This is a positive coterminal angle. Now let's talk about our negative angle of rotation. Now there's a few ways that you can do this. All right, so we're rotating in a negative direction. So once again, I'm going to go to here. Now, that's my angle, okay? That's my 160-degree angle. But here's the thing. I want to now, from there, rotate backwards. So I'm actually going to reverse direction and stop at the same terminal side. Okay, so I started out with 160 degrees. But then I rotated from there backwards one full rotation. So I'm actually subtracting 360 degrees from that initial rotation of 160. and that's going to give me negative 200 degrees. Now, mathematically, what you can see is that to find any coterminal angle, I can either add 360 or I can subtract 360. Visually, it might look a little bit different. If I wanted to find, let's say, another positive angle of rotation, I could think about rotating on my picture a full rotation, or I can say, well, I already know one positive angle of rotation is 520 degrees. I can add 360 degrees to that. Do another rotation, and then that's going to give you, 880 degrees. So I could continue to find coterminal angles in this manner, and I could subtract 360 degrees to find coterminal angles. All right, let's try another one. So this time my original angle is negative 63 degrees. So the first thing I'm going to do is I'm going to draw the angle. So I'm going to have my initial side along the x-axis. But this time, instead of rotating in a positive direction to get 63 degrees, I'm going to rotate in a negative direction. So remembering again what we talked about a moment ago, if I rotate to the negative y-axis, I'm going to be at negative 90 degrees. If I rotate all the way to the negative x-axis, I'll be at negative 180 degrees, and then negative 270 degrees, and then negative 360. So I'm rotating in the opposite direction. I'm rotating clockwise, and I need to rotate negative 63 degrees. Now, I'm not going to go all the way to 90 because that's too much, but I need to go closer to negative 90 than I am to 0. So maybe my rotation looks something like this. And then I draw in my terminal side, and there's my angle of negative 63 degrees. Okay, next up, we need to figure out what quadrant we're in here. So if we label our quadrants 1, 2, 3, and 4, we can clearly see that we are in quadrant 4. Okay, and then next thing we're going to do is we're going to find a positive coterminal angle and a negative coterminal angle. Now, just like we did before, to find a positive coterminal angle, we're going to reverse direction here because our original rotation is to here, negative 63 degrees, but then I'm going to change direction and rotate a full 360 degrees. So what I started with was negative 63 degrees, but then I add 360 to it, and that gives me 297 degrees. So that gives me a positive angle of rotation, coterminal angle. Now I'm going to do the same thing to find a negative coterminal angle. So again, I start out rotating to that angle that I'm trying to find a coterminal angle for. And this time I'm finding a negative coterminal angle. So I'm going to continue rotating in a negative direction, one full rotation past the original angle. And then I end up back where I started. So I have negative 63 degrees was what I started with. This time, since I'm rotating further in a negative direction, I subtract 360 degrees. And then that will give me 423 degrees, or negative 423 degrees. Okay, so I want you to pause the video here and try the next two on your own and come back and check your answers. Okay, so let's take a look at these. We'll take a look at C first. You can probably see both of them on the screen at the same time here. So for part C, I drew my angle. It ended up being in quadrant 3, had to be bigger than 180 but less than 270. To find a positive coterminal angle, I'm just going to take that 235 and I'm going to add 360 to it, which gave me 595. And to find a negative coterminal angle, I'm going to take 235 and subtract 360, and I get negative 125 degrees. Now, part D was a little tricky because when you initially draw the angle, you actually have to complete a full rotation of 360 degrees and continue past that to get to 400 degrees, because 400 degrees is more than one rotation. So this actually represents a 400-degree angle. But what's important about this is that you actually show how you rotated a full 360 degrees and kept going. Without this showing the direction, I can't tell if that's a 400-degree angle or just a 40-degree angle. So to find a positive coterminal angle, you probably all started out by taking the 400-degree angle and adding 360 to get 760. Absolutely fine. That is a positive coterminal angle. But then when you went to do a negative coterminal angle, you took 400 degrees and you subtracted 360. And you ran into another positive coterminal angle. This is not negative. and I'm looking for a negative coterminal angle. So what I have to do is take that 40 degrees and continue to rotate backwards another full rotation to get the negative 320 degrees. All right, next up is we're going to talk about radians. So to create a radian, what we'll do is we'll take one radius of the unit circle and wrap it around the outside of the circle. Now, you may have done something similar to this in geometry or possibly even in Algebra 2. But one radian is the measure of the central angle that intercepts an arc that's equal to the length of the radius of the circle. Sounds really confusing. I'm going to put a link on Classroom where you can actually watch the construction of a radian. So you'll want to go look at that now and then come back. So to get completely all the way around the circle, hopefully you figured out that it would take 2 pi radians for one rotation. So instead of 360 degrees, now we're talking about 2 pi radians. Now the key to finding coterminal angle in radians is it's exactly the same as it was up above. It's add or subtract one rotation, but this time our rotation is 2 pi. So we're either going to add or subtract 2 pi. So just like we did above, we're going to do 4 things here. We're going to draw the angle in standard position, state the quadrant, then we're going to find a positive and a negative coterminal angle for each of the following. So let's start out with 3 pi over 4. Okay, so in order to really understand what's happening here, we have to understand. So this is 0 radians, but if we rotate all the way around and come back to that positive x-axis, that is also 2 pi radians. So let's start really thinking about then, what are the other 3 parts of the axis going to be? So if we rotate from here to the negative x-axis, we're rotating half of a rotation. Well, that's half of 2 pi, which is just pi. And then think about what happens if you rotate from here to here. Well, you're halfway between 0 and pi, so that's just pi over 2. And then what happens if you're rotating from here to here? Halfway between that, this is 1 pi, this is 2 pi. Halfway between 1 and 2 is 1.5, which we write as 3 pi over 2. So those are what we know. If you get confused, you need to think about the fact that this guy is like half pi, or you could also think of it as 0.5 pi. You can think of this as 1.5 pi or as 1.5 pi. Those may help when you start trying to figure out where do we draw our angle. So to start with 3 pi over 4, well, you can think of that as either 3/4 pi or 0.7 pi. Or 0.75 pi, in which case you might be able to understand then we're going to be somewhere between 0.5 pi and 1 pi. In fact, we're going to be halfway between those two. So when I go to draw my angle, again, I start the same way I did last time with my initial side, and then I'm going to rotate to 3/4 pi and draw in my terminal side. So this angle is 3 pi over 4. Now, as far as quadrants go, I'm hoping that you can easily see that that is in quadrant 2. Okay, so now comes the really fun part, figuring out a positive and negative coterminal angle. So let's start with a positive coterminal angle. I'm going to do this exactly the same way we did in the previous problems. I'm going to rotate to 3 pi over 4, and then I'm going to rotate another complete rotation. So what I did was I started out at 3 pi over 4, and then I added a full rotation, which is 2 pi. Okay, so at this point, you're really just adding fractions together. Remember, I'm of the opinion that whenever you see one fraction in a problem, you should probably make everything a fraction. So really what I'm doing here is I'm adding 3 pi over 4 to 2 pi. In order to do that, I have to have common denominators. Well, that means I'm going to have to multiply this fraction by 4 over 4, which really means I'm taking 3 pi over 4 and I'm adding 8 pi over 4, one full rotation. And what that gives me is 11 pi over 4. This is my positive angle of rotation. Okay, so let's now do negative. So just like we did in the previous part of this, I'm going to rotate to the angle I want, but then I'm going to go backwards one full rotation, back to where I started. So remember, that means I started at 3 pi over 4, but then I subtracted one full rotation. Now look, we just got common denominators a minute ago, didn't we? So we know that this is just 3 pi over 4 minus 8 pi over 4. And what we end up with is negative 5 pi over 4. And there's our negative angle of rotation. All right, let's try one more together, and then I'll have you try a couple on your own. So I went ahead and labeled the axes here with the negative angles, just rotating in a clockwise direction, just like I did in the previous problem. And remember, half pi or 0.5 pi, 1.5 pi or 1.5 pi can help you when you're trying to figure out where to draw your angles. So negative pi over 4. Let's think of that as negative 1/4 pi or negative 0.25 pi. Okay, so that might help us visualize where this angle will go. So I'll start with my initial side on the positive x-axis, and I'm going to rotate backwards 0.25 pi. Well, I know I'm not going to go all the way to here because that's half. So I'm going to stop somewhere in the middle here, draw in my terminal side, and now I've got my angle of negative pi over 4. As far as quadrants go, that should be an easy question. I'm just going to write it down here. It's quadrant 4. And now we have to work on finding our positive and negative coterminal angles. So just like we did before, rotate to the angle you want. And now since I want to find a positive coterminal angle, I'm going to change directions and go in a positive direction, 300 or one full rotation. So what I have is I started out at negative pi over 4, and then I added a full rotation, which because we're talking about radians now, it's 2 pi. Now we have the same denominator we did a moment ago, so this is just negative pi over 4 plus 8 pi over 4, and we end up with 7 pi over 4. Okay, now to find a negative angle of rotation, I once again start by rotating to the angle I want, which is negative pi over 4, and then continue this time because I want negative to rotate in a negative direction, another full rotation until I end up where I started. So I'm at negative pi over 4, and this time instead of adding 2 pi, I'll subtract 2 pi, which we can probably easily figure out is just saying subtract 8 pi over 4, and what we end up with is negative pi over 4. So our positive angle of rotation is 7 pi over 4, negative is negative 9 pi over 4. Okay, I'm going to pause the video here and try the next couple on your own. All right, so take a second, check your answers. Just like in the previous problem with degrees, the first time in part D that you actually try to find a negative angle of rotation, you still end up with a positive angle. So you have to take that positive angle and subtract another rotation. All right, well, let's move on. All right, so up till now, we've looked at 2 different ways to measure angles, in degrees and in radians. There is a way to convert radians to degrees and degrees to radians, but what I want you to think about is this. So one full rotation is 360 in degrees, but it's also 2 pi in radians. So I'm thinking in terms of degrees over radians. Now, 360 and 2 pi are both divisible by 2. So we could then say, hey, let's just reduce that fraction I wrote a second ago to this. This proportion is really important. So this gives you basically a way you can always convert from radians to degrees or degrees to radians. You don't have to remember a different conversion factor each time. So for instance, let's go ahead and try one. So if I wanted to convert from degrees to radians, so 90 degrees, I want to convert that to a radian measure. Now you might already know what that was, and that's good. But what I'm going to do is this. I'm going to set up a proportion that has degrees over radians. So let me let me kind of just use what I have above here. I have degrees over radians equals 180 over pi. So I'm going to start with the 180 over pi. And I'm going to set that equal to whatever I have. So I'm given degrees. I'm given 90 degrees over what I'm trying to find. So what I'm trying to find is the radian measure. I'm just going to call it r. And then this is a simple proportion. All we have to do is cross multiply and solve for r. So I end up with 180 times r equals 90 times pi. Now remember, my goal is to solve for r. I want to know what the radian measure is. So I'll have to divide both sides by 180. And then that's pretty simple, guys. You've got a fraction, 90 pi over 180. Just simplify 90 over 180. That's just 1 pi over 2. And you don't need to write the 1 there. You can just write it as pi over 2. Okay, let's try a couple more. So let's try one that maybe you can't figure out just by looking at it. So let's do 120 degrees, okay? So I'm going to set it up the same way. I'm going to take the angle I'm given, divided by, let me redo that, sorry. I'm going to always start with my given proportion, which is 180 over pi, so degrees over radians, equals whatever I'm given. So this time I'm given 120 degrees, so it goes on top, divided by, and then radians. So I need to solve for r. So once again, I can cross multiply, and I get 180 times r, and I'm not going to use the degree symbol because it's going to be irrelevant here in a moment, equals 120 times pi. And then once again, my goal is to solve for r, so I divide by 180. And what I get is that the radian measure is whatever 120 pi over 180 is. Whoops. Now I can right away simplify that to 12 pi over 18. And then I see that both of those are divisible by 6. So I would make that 2 pi over 3. All right. Why don't you pause the video and try F. Actually, try E and F, and then come back and check your answer when you're done. All right, so take a second, check your answers. You should have gotten 5 pi over 4 for the, or negative 5 pi over 4. Oh, I almost made the mistake that you guys always make. It's negative 5 pi over 4. And then should have gotten 3 pi over 20 for 27 degrees. Okay, let's try going the opposite direction this time. So this time I'm going to go from radians to degrees. I'm going to start it the same way. And I'm actually going to show you 2 ways of doing this. But I'm going to start the same way. I'm going to start with my proportion, 180 over pi, equals, now this time I have to consider the fact that I'm finding a degree measure and I'm given a radian measure. So I'm finding degree and I'm given a radian. Now that may look confusing, but you're just multiplying cross products. So you're going to do 180 times pi over 6. Think of that as 180 over 1, equals pi times d. Now remember, we're going to solve for d. I'm going to simplify this a little bit first. So the 180 pi over 6, that's just going to end up simplifying to be 30 pi equals pi times your degree measure. And then we want to solve for d, right? So we're just going to divide both sides by pi. And what you end up with here is that your degree measure is just 30 degrees. Now there is a little bit of an easier way to do this. And if it comes from you understanding that pi in radians is the same as 180 degrees when you're talking about a degree measure. So anytime you see pi, like I see here, I can really just think of that as 180 degrees. So really all I have to do is take 180 degrees and divide by 4. And that's going to give me my degree measure. So it's actually a little bit quicker to convert from a radian measure to a degree measure. Let's try another one of these that's on here. So we'll try 7 pi over 6. So think of pi as 180 degrees. And then really what you have is 7 times 180 degrees divided by 6. That's going to end up being 210 degrees. I'm not going to go through all that multiplication because I'm thinking you can probably do that part with a calculator pretty easily. So why don't we pause here and you guys go ahead and try G and I don't know, C and G. Try them and see what you get. And then come back and check your answers. All right, so if you use the shortcut, it's pretty quick and simple. Not a whole lot of issues there. All right, nice work, guys. I know this video was long. Thanks for sticking it out. I'll see you in the classroom.